Welcome to Physics with Mr. Brazil. Today I'm going to show you how to do a tension problem. This is a question I've used on a test. So we want to find the tension on two cords that are attached to a 15 kilogram weight due to some force. Now, we need to make some statements here. Let's assume that these, or not assume, but that these tensions, T, these two cords, they're at equidistance from the center, so there's no unusual torques taking place. Well, first we need to find the acceleration of this whole system as it goes upward. So that means mass total times this acceleration, which is a positive direction upward. So let's find the net force of the system. And that is the force F positive minus, and I'm going to say FG35, that's for the mass, that's 35 kilograms, minus the force of gravity for the 15 kilogram, and that equals a mass total, A. Well, let's solve for A. A is going to equal force minus FG35 minus FG15 over the total mass. Now, let's separate things out so we can see what's happening. So we have the mass of the 35 times g minus the mass of the 15 kilograms times g over the total mass. Something interesting is happening here. Check this out. If I put the mass total under each denominator, we're going to end up with something that looks like this. The force itself will be divided by the total mass minus, check this out, minus the mass of the 35 plus the mass of the 15 divided by the total mass. Well, that equals 1. In other words, minus 1g. So in other words, the acceleration itself is going to be the force divided by the total mass minus g. We're going to need this information. So let's move this out of our way so we can do some other math. Okay, I'm going to make this a little smaller and put it aside so that we can use it for later if we need it. Okay, we're ready to rock. So now let's find our tension on our two cords. Well, that's going to be the net force, and I'm going to say in the F direction. So that's going to be 2T positive minus just F sub 15 and the mass of 15 at the acceleration A. In other words, this is going to be a subsystem right here that's going upward at M15G. That's important to note. Okay, let's go on and try to do this math. Okay, so now let's get T all by itself. So it's going to be T equals M15A plus FG sub 15 over 2. Let's separate that out. In other words, let's put A in. We know that it's F over the total mass of the system minus G plus mg sub 15g over 2. Notice that I'm using variables. It's better to move around variables than moving around numbers, and you'll see in the end. So what we're going to have here is mass sub 15 divided by mass total times F, and minus m sub 15g. Ooh, mass of 15g, this is going to be 0. That's going to cancel out all this divided by 2. So our answer turns out to be F sub 15, 2 times the total mass times F. Well, let's plug in our values. So we're going to have 15 kilograms divided by 2 times 35 kilograms plus the 15 kilograms. Okay. And that's going to give us 15 over 100 F. Well, let's reduce that. All that it's going to be is 3/20 F. And that is our solution to the problem. So that will be the tension for each cord that's holding onto that 15 kilogram mass. Hey, keep on physicsing and keep practicing this stuff. This also works in the horizontal direction. I should have some videos you can find. Have fun. Bye.